let's do a bit of recap on a little bit of stuff that we have learned in chapter 2. So in chapter 2, we are exposed to the 4 kinematic equations, or as I usually like to call it, the Suvet equations. So using these 4 equations, we are able to solve problems involving situation where the acceleration is constant. So we call this kind of situation either uniformly accelerated motion if it's in 1D, or if it's in the air and it's only influenced by gravity only, then the motion we call it projectile motion, and it can be in 1D or 2D. So 1D will be the freeform motion. Okay, so we know that for projectile motion, in the y dimension, you have a constant acceleration of negative 9.81 meter per second squared, whereas for the x dimension, you have 0 meter per second squared, which is constant velocity in the x direction. So this is what you learned in chapter 2, and if you remember from the first few videos for chapter 2, I've mentioned that chapter 2 we learned how to analyze and predict motion. So we look at the motion, we try to describe a motion using kinematic quantities like displacement, positions, velocity, acceleration. We use that to describe a motion. And of course, we use these 4 equations here, then we are able to predict what will happen to an object 5 seconds later, or what will be its final velocity before it reached the ground. So we are able to analyze or describe motion. We are able to predict motion using the idea that we have learned in chapter 2. So chapter 2, these kind of things we call it kinematics. Now we move on to chapter 4. For chapter 4, we will try to study why the things move the way it moves. Okay, let's say if we study projectile motion, we know that it will trace a parabolic path, right? So chapter 4 will allow us to know why does the object travels a parabolic path. Why does not it travel a U shape? Why not a U shape, but why a parabolic path? So dynamics will allow us to understand, or it allow us to explain why things move the way it moves. Okay, so I'm going to give you a rough overview for chapter 4. So chapter 4, I have one single sentence which I think is a core concept for chapter 4. Okay, it's a sentence with many words that you might not have heard before. Okay, so net force changes the state of motion of an object. So net force is a new term. If you have not heard of it in SPM before, change is something that you know, but state of motion might be something new to you. Okay, so for state of motion, I've actually explained it quite clearly what is state of motion in my website on section 0, state of motion. But I hope you all can watch through the video to have a better idea of state of motion, because I'm going to just explain it briefly over here. Okay, so how does it work in this chapter is we will learn the 5 forces over here, the 5 different types of forces that we can observe in a macroscopic situation. So you have your weight, your tension, your external force, your normal force, and your friction. And for friction, we will classify into 2 different types of friction, which is kinetic friction and static friction. Okay, so after learning these 5 types of forces, we will use a free body diagram to illustrate whether these 5 forces are they acting on an object or not. If they are acting on an object, what direction is it acting at? What is the magnitude? How do you represent all these forces acting on an object? We will use a free body diagram. So this diagram will help us to illustrate all the forces that is acting on an object. Okay, then after we have this free body diagram, we can use the idea of summation of vector in order for us to determine if all these forces are acting on an object, what will be the resultant force, or what will be the effect, or what will be the final force, final summation of forces. If I add up all these forces together, what will be the resultant force, or the net force? So this net force here, this new term here, it means the vector sum of forces acting on a particle or a body. So we learned before in chapter 1 that if you have a vector A, a vector B, a vector C, and a vector D, you can add them all up together to find vector A plus B plus C plus D, right? A new vector if you sum them up. So it's the same idea here. We have weight, we have tension, we have external force, we have normal force, we have friction acting on an object. Net force will be if we sum up all these forces that are acting on an object. If we sum up all these forces, then we get the net force. Okay, it's not an actual force that is acting on an object, but it's the result of multiple forces acting on an object. Let's say if I have weight pointing down, I have normal force pointing out, then my resultant forces will be having this side of the forces cancel out this side of the forces or something like that. Okay, basically you sum up all the forces. It's the effect of summing up all the forces. Okay, so because we have net force, then it will cause something. Okay, so what does it cause? It causes a change. Okay, because net force change. Net force will cause some change to the state of motion. Okay, state of motion, if you read in the website, state of motion means what state is the motion of an object is. Okay, so if the object is moving at 5 meters per second to the right, 5 meters per second to the right is the state of motion of the object. The object is in the motion in what kind of state? 5 meters per second to the right. Okay, if today it changed from 5 meter to 6 meter, then you say the state of motion changes. Okay, if the 5 meter per second to the right remains the same for 1 hour, then you can say the state of motion does not change. Okay, so if you want to say state of motion change, then it means by before that is 5 meter per second to the right, then probably later it's 6 meter per second to the right, or later it might be 5 meter per second to the left, or it might be 0 meter per second. So it's either a change to the magnitude of the velocity or a change to the direction of the velocity. If any of it, if the magnitude or the direction of the velocity change, then the state of motion change. Okay, because it's not in the same kind of motion anymore. Before that is 5 meters per second to the right, later it's not 5 meters per second to the right. So we call it a change in the state of motion. Okay, so state of motion, as I mentioned with a few examples just now, it's about velocity. 5 meters per second to the right is velocity. So if I say if your velocity is constant, that means your state of motion is constant, it doesn't change. But if you change state of motion, that means your velocity will change. Okay, so net force change the state of motion of an object means net force will change the velocity of an object. So if net force causes change in the velocity of an object, it means net force causes acceleration for an object. Okay, because change in velocity, as we know, if a velocity change, that means the acceleration is not zero. If you have a non-zero acceleration, that means you are having a change in velocity. So net force causes acceleration to an object. And if you are clear, if you remember something from SPM, that means net force or resultant force is related to acceleration. And if we can do a bit of recall, it's related to sum of F is equals to m times a. So sum of F here is the net force equals to m mass times a acceleration. Okay, so because you have net force, therefore you experience acceleration, therefore the velocity of an object changes. Okay, if there is no net force, then there will be no acceleration, then there will be no change in the velocity of an object. That's the idea behind this equation that you have used a lot in your SPM. Okay, so I've mentioned that we'll start from here, identifying these few individual forces. Then we'll learn about free body diagram, how to illustrate them to show all the forces acting on an object. Then we'll use the technique of summation of vector from chapter 1 to determine the sum of forces. Okay, we'll do it for the x component and the y component, just like how we usually do it. Then we'll relate what we learned about net force, we relate it to acceleration, which is what we have learned in chapter 2 on kinematics. Acceleration. How do you relate them? You relate them using sum of F equals to ma, which is also Newton's second law. Okay, so we'll learn all this, how force and acceleration are related to each other. We'll learn all this through the 3 Newton's law of motion, which is the first law, which will explain state of motion. The second law will explain sum of F equals to ma. And third law will explain about action reaction, but I still can't figure out how to put it into this big picture. Okay, so this is chapter 4, a rough overview of what you will learn throughout this whole chapter.